afternoon, everybody. Very good to see you all. I've been coming back onto the Berkeley campus quite a bit lately. I think that must be only because of one reason, because a lot of AI is happening actually in this school. A little bit about myself, and then I'm going to introduce Amr. So I was an entrepreneur myself. I built a company in the 1990s called BEA Systems, which at the time was a premier middleware company. And we quickly got to our first $100 million revenue, went public, and then pivoted the company to become the premier web application server company. So our product is called WebLogic. It's still, by and large, most of the commercial websites still using this technology to this day, most banks, most telcos, et cetera. And the company eventually was exited and sold to Oracle in 2008 for $9 billion. And I've been an avid studier, student, and an investor in various data and data-related technology. Many of the companies are actually from UC Berkeley. And just having a grand time, so it's, lately, obviously, because of Gen AI, every conversation is around that and how this actually going to be applicable into the world that we're mostly in, which is in enterprise computing in the B2B space. With that in mind, I met Amr recently, and in a very similar trail, because of the interest of investing into Gen AI. And Amr is someone that I have admired for a very long time. Actually, this part of the story, I've told you how I actually got to know about you. Not just through other colleagues in investing, but there was actually a story itself. So my CTO at BEA is a guy called Mark Karges. Mark Karges, that name may ring a bell. Mark Karges, after he left BEA, became the CTO of eBay. Oh. So eBay, for the longest time, actually outsourced most of the technology development. He was the guy that single-handedly brought everything back in-house, and he became the largest and the first adopter of Hadoop, which is the first big data database for eBay to learn about the customer, their behavior, and what they search and what do they buy, and be able to go after and basically market to them very, very successfully. So I have been interested in Hadoop basically from the get-go. And I was the founder of Cloudera, which is the Hadoop company itself. So I've been a huge admirer. So to be honest, I tell you, I'm fascinated about your story at Cloudera. Tell me about how did that come about? I know there was a project inside Yahoo. You was there, and then it got spun off, and then you guys, you and Mike Olson created this company. And tell us a little bit about how it transpired, because it's extremely applicable to this generation of company, that what they're trying to do, and what have you learned, how you would do things differently, and we can talk about the current new company. Yeah.
Yes. Thank you. So thanks for the amazing introduction. Cloudera was born out of need, actually. So while I was working at Yahoo, I was not in the team that was building out this amazing new project called Apache Hadoop, which is based on the MapReduce principles from Google. I was in a team that was leveraging the data that Yahoo has to activate insights within the organization and make it a lot more productive and make it a lot more impactful. And we were struggling with the volumes of data and how fast they're growing. We were struggling with the fact that data wasn't just structured data, it was semi-structured and completely unstructured. And the fact that there is new types of questions we want to ask out of the data that go beyond what SQL can do for us, for those of you that know what SQL is. So it came out of that need that I had a very important query actually in my system. It was called the monster query. It was a very, very big query that correlates all the ad impressions and the ad clicks and the content impression and the content clicks across all of the Yahoo properties. And that query wouldn't finish on traditional relational systems. Like we would run it on some databases. There is a company, their name starts with the letter O. I'm not going to say their full name. We would run it on their database, and it would take like 2-3 days and then crash, and we don't get the answer. So we absolutely needed something new, and we knew that is a must for us to proceed and to grow in terms of analyzing data. And then we bumped on this team building this new thing, and they said, try it out. And I tried it out, and it just worked. The thing that was taking days was finishing in minutes for a fraction of the cost. And it came out of this very clear technological inflection point of how we do data processing. In the past, it was very monolithic. You just have one server, and everything is happening in there. And then Google publishing the MapReduce paper introduced this new technological approach of divide and conquer, which is very standard CS 101 technique for making things go faster. Let's break out the problem over many, many, many servers. We call them pizza boxes because they look like pizza boxes if you have ever been to a data center. And then spread all of the data and all of the compute across all of them. And voila, it just worked. So for me, that was the trigger. Like, it came out of my need first, like I had the problem, and then I saw how the technology just solved it in a way that's way more perfect than anything I've experienced before. So whenever you find something like that, that's when you leave and create a company. So that's my advice to you. If you experience that in your career, that is it. Like, that's the signal that there is something here I should be pursuing.
I mean, actually, it's very similar to mine because I was helping Sun, which I was working for. Sun Microsystems at the time, it no longer exists. Was a quintessential computer company. Many people call it the predecessor of Google because culturally and the people were involved. And we pivoted the company from a desktop company into a server company. And then the first thing we ran into, same thing. We were migrating a mainframe database onto the old company's database. And then that was, at this time, quickly a crash. We couldn't back it up. And then I invented some software to split the jobs, both on the computer and on the storage side, onto multiple servers. Back in those days, we didn't have cloud, so they were sitting in the same room, and to allow the job to run. Exactly. So needs is, I think, it's very crucial. When you have those needs, that would be great genesis of company. So tell me a bit more about like a Cloudera story. So Cloudera was formed. Cloudera was a very unique company because it's religiously hang its head on open source, right? No closed source whatsoever. And then providing a lot of the services and support around the open source itself. What do you think of that model? I mean, looking back and they say, how will you do things, the same way or differently, based on that, the experience?
Yes. So commercializing open source is actually hard. It's really hard, and if you don't know what you're doing, you might think you're succeeding when you're actually failing. And the reason why is open source has advantage of course, getting you the developer community to engage with you. They help you make the product better. They help develop with you. They help fix things for you. And the word of mouth effect makes the open source get distributed a lot more faster. But if you're not careful, what angle am I going to be able to create a business around that with? You're not going to create a successful business. And there's some examples of that in the past. The Apache web server, which I would say is the most popular open source ever, project ever. No company was able to monetize it because the open source itself was so good that you didn't need anything else. I don't need support. I don't need tools. I don't need engineers. I can just run it myself and it works. So you have, my key advice to you is whenever you're doing an open source project is great, do that, but always keep in mind how am I going to create value out of that. For my company, assuming you want to create a company. If you just want to create a successful open source project, there's nothing wrong with that. It's also awesome. But if you want to create a business and get investors to work with you and help you grow it into a mega corporation, you need to have a very clear angle how I am going to monetize that. So some of the approaches for monetizing, one of them is what we call open core. So the core of your open source is open, but then you have tools around the core that make it easier to operate that are not open. So that's one approach. Another approach is just support. Like, I'm going to give you the open source, and if you need support for the software, I'm one of the best people that you can work with to get the support. Another model is that has been enabled now with the cloud movement is the open source goes out there, the people use it, like Spark, for example. Some of you might be familiar with Spark out of Berkeley. And then once they use it, they say, this is awesome, but we would like somebody else to run it for us. Can we just use a cloud service that brings us that back? And that's kind of the Databricks business model if you're following them. So the key message though, like there is only one thing you remember from this whole sentence I just said right now is always, if you want to create a business about your open source project, from day one, be thinking about how you're going to do that, because if you release too much into open source, you won't be able to undo that. That's it. And that might be hard for you to create a business out of it.
Yeah, this is probably the best memory I have at Berkeley was dating back just over 10 years ago, across the street literally from here, meeting with Professor Jan Stocker for the first time. They were working on Spark with a bunch of graduate students and postdoc and visiting professor. And that was one of our challenge was, it was fully open source at the time. So what would we do differently? It turns out for this transition onto the cloud, which this the big difference in this case with now the data lake and our data lakehouse, it runs solely on cloud, is to basically control that all the tooling around that was all closed source. So there's a reason for the customer to basically deploy onto the professional version of the software. And that model works out really well. So the software continue to innovate openly in open source, but yet at the same time, which also draw huge amount of inbound interest of, who are the people that we're buying the professional version of the software, while we actually were able to build a very successful commercial company. And I think that's kind of been ingrained very much into the Berkeley spun-off type technology company, a ton of them, based on that.
I would say that's a new chapter in Berkeley's history, because Berkeley wasn't like that in the past. Berkeley, like FreeBSD. FreeBSD is one of the most popular open source Unix variants there are, but there was no thinking, how can we create a company out of that back then? It's like, here you go, world, here's an amazing thing called FreeBSD. But you look right now at the success of Databricks as one of the very first examples of now Berkeley getting serious, like Stanford. I'm from Stanford, don't count that against me. Showing that model can work very well as well and can have multiple rewards on the world and impact in a very significant way. So I'm glad to see Berkeley following the footsteps of Stanford.
Hey, it's perfectly okay for a UC guy to work with a Stanford guy. It's okay, it's all right. In the name of innovation, we can all do that. So Simon, let's talk about your new gig here. So after spending a couple of years at Google, you have decided that it's time to go back onto this entrepreneurship journey. So you met your two co-founders who both worked at Google. Tell us a little bit about Vectara. How did it come about? And obviously Vectara has been around for a couple of years. So this is before GTP3. GTP4 was hot. And I don't know why someone would create a LLM company that's specifically for Warland data, for your own data, and creating a whole platform for people to build applications in this stuff, and allow me to come work with you. So it's almost like a jewel got landed on my lap. So tell me about the story. Yeah,
I will. So first, very briefly, Vectara, for those that don't know about us, it was very hard to explain what we do a couple of years ago, and even last year it was hard. Now we just say it's ChatGPT for your own data. Right, so it became easier now for people to understand what we mean. So imagine taking all of your notes from all of the lectures you're attending, all of the seminars you attended, and then you have all of these notes now ingested by a system where you can ask questions to it and just like converse with it. Oh, the last time when I was attending CS 105, what were the top 3 points that I heard in that lecture? And they will come up. And oh, can you tell me more about the second one? And it will just come up. So this way you're conversing with your own data, whether that be personal data or company data. So that's kind of what Vectara does. First, like, why would you start a new company, or why would you invest in a company? I'm now building my own framework for how I do that. And for me, it's 3 things. There is 3 things. If I find these ingredients, I'm either investing or joining. Like, that's kind of, or starting. So what are these 3 things? People, amazing people that can truly deliver on that thing and believe in that mission and have the optimism and have the passion that we're going to change the world with this. That's number 1. Number 2, a technological inflection point. That's my preference. I always like to look for something which is not just an incremental feature here or incremental feature there. No, it's an inflection point that will change what we have been doing in the past in a significant way. So again, if you go to Cloudera, it was about divide and conquer across many, many servers at scale. Now with this large language model, it's about algorithms that can truly understand what we mean when we speak or say something or write something. So look for that. Look for technological inflection points. And then the third thing I look for is you can make money from it. Otherwise, you shouldn't be starting a company. So these are the 3 ingredients. So the story for Vectara is my co-founder, Amin. He was at Google Research, and he was one of the very early people working on these large language models that truly understand human communication in any language, and not just in English, in any language. And the models were able to build almost the equivalent of a lingua franca. I don't know if you know the concept lingua franca. It was something that was attempted many years ago to try and create a language that the whole world can speak. So we don't have English and then Japanese and Chinese. No, we all just speak one language. Obviously it failed, but they tried. Now these models now have built that inside of their brains, so inside of the neural networks. Like the neural network can take English and map it to the same meaning if it was expressed in Chinese or Japanese or Korean or Spanish or Italian, it doesn't matter. It goes back to that same meaning. So the words right now map to the meaning directly. And that has never been done before. So Amin was in the middle of that and he witnessed that. Now here is the funny story. Amin, my co-founder, he pitched me to invest in this. So I also do angel investments in 2000. He left Google in 2000. I was still at Google at the time. Sorry, I mean 2020, not 2000, 2020. And I looked at it and I said, this looks great, but I don't think you can do this outside of Google. I think you need lots of GPUs and TPUs and storage and data to be able to do this. And that was my mistake, not seeing the art of the possible. And I declined to invest in Amin. Amin had another co-founder with him. His name is Talat, also from Google. And they proceeded to implement that system themselves on top of AWS. And within a year, they met with me again, and they had the whole thing running. And they only spent for $100,000 to make it happen. So as soon as I saw that, the ingredients all came into place for me. Amazing people that can build things that other people can't build easily, 10x developers, but if not more. 2, an inflection point in technology. We can now understand meaning at a level that has never been done before in history. And 3, the conviction that if you can truly understand meaning, there is unlimited applications that you can enable and hence make money out of by doing that. So that was it. That was like, I'm teaming up with these people. We're gonna change the world in a very positive way.
And when actually, this is a very serendipity because in 2021, 2 years ago, the academics of me published a paper to talk about a subject called predictive computing. Predictive computing is what I predicted finally after 50, 60 years. This concept of a form, we constantly struggle. Everything that we do on the web today or on a mobile, we're filling out a form. It's just like we walk up to, the DMV and filling out this form. We're still doing it, and we're submitting that form. It's on our own responsibility of triggering off and committing to that transaction. I think the time has finally come that we will be able to change that. And having a way that is much more natural in the way that we work like a chat. So we will send a set of natural language and say, oh, I'm actually looking for an answer for the following things. And intelligently, the system gather up all the data, using obviously the things that they put inside the vector database, and come back with an answer that's satisfactory. I think the next decade, we're going to start seeing applications are going to be self-administered. We will not be opening up our phone, going to applications, filling out the field, and triggering out to do things. It will be completely reversed. It will be able to learn where we are, what our behavior, and automatically do it for us. Yes, and I think that's really is what Vectara is focusing on, is enabling those companies to be able to build these applications.
Yes, very, very, very well said, Alfred. Like, I look at what's happening right now. It's very similar to the iPhone moment. Meaning when the iPhone came out and we had this touch screen where we can use our finger now to do stuff, before it was the mouse and menus, the human-computer interface changed, right? And we all loved that a lot more. Wow, I can swipe right, I can swipe left, I can zoom in and zoom out, and I can do all of these amazing things with my finger. That's awesome. It became a much more natural human-computer interface for how we get stuff done. And what's happening right now with this cognitive motion, or the generative AI motion, is we're now able to interact with computers in the same way we interact with another human. So imagine you want to sign up for a class, or you signed up for a class and you're not doing well in that class, and maybe the grade is not going to be great, so you want to drop out before the deadline. And now you have to go navigate the menus and search inside of Berkeley, where do I go, how do I do this, and until you eventually find, oh, I have to drop before the deadline, and you do it. Versus just telling the system, please drop me from that class. And the system says, thank you, done. Or the system says, please give me a reason for why you're dropping. You say the reason, thank you, done. That's how the world is going to be in the future. In the future, it's much more natural for us to interact with machines by just saying what we want, whether that be verbally or by typing it down. And that's how we see the world evolving right now. Every single application will be re-architected to work in this way, in the same way that iPhone caused all of our applications to be re-architected.
So obviously you answered part of the question, which is, given GTP3 is dominated at this point in time, obviously by OpenAI licensing it and having this monster deal that they've done with Microsoft, that Microsoft, I think this is to quote Microsoft directly, the CEO of Microsoft has said, this is their moment that they have no revenue generated from search, and it's a perfect time to go bury the competitor to generate 100% of the revenue based on search. But it's obviously that's one of the fears is this is going to be extremely dominated by these very large monopolies. So people like us that wanted to build business, how do we do it? I mean, Vectara would be one example, which is the Walden internal data of enterprise. They still need technology to be able to do very similar thing. And then maybe the very last mile, sometimes we'll use a bit of GTP3 to construct the rest of the story so that it looks bigger than life, right? So I imagine that will be the case. So given that, so GTP4 just got announced, we all saw the demo. Now you can literally scan a notebook and then an app comes out. So what's your take on GTP4 and how that will affect where this is moving to? Because I think we're now at a neck-breaking pace in terms of innovation for Gen AI.
Yes, excellent observation. So first, on the wars that are happening between Bing, Microsoft Bing, and Google, I think that's a healthy thing, right? Because you want to have balance in terms of who controls the knowledge of the world. So I think that's a good thing that's happening in front of our eyes, and it's surely very amusing to watch how Satya Nadella and Bing are coming in and saying, "Oh, Google makes all of their money from ads. Let's give answers right away, so you don't need ads anymore, and we don't care if we don't make money from it because we're not making money from it anyway." So it's going to be very, very cool to watch how that evolves over the next couple of years. But in terms of the large language model dominance and the companies that control them and how that shape the future, I look at this motion of having these technologies that can now understand our thought processes and how we think and how we operate. Is that the analogy is so strong with the Industrial Revolution. It's almost exactly the same thing happening again, maybe at much faster speed. So what happened in the Industrial Revolution? What happened in the Industrial Revolution is we figured out how machines can make stuff that we used to make with our hands way quicker than we can make it with our hands, right? So this T-shirt I'm working, this piece of cloth used to take our ancestors months to gather the cotton and turn the cotton into threads and then turn the threads into a sheet of cloth and then turn the cloth into a shirt. Now you put the cotton on one end and the thing comes out on the other end, right? So back then there was lots of people that said, oh, the people making the machines that manufacture the cloth are going to be the winners. And they were winning, yes, because they were selling these machines, but the true winners were the ones who figured out how can we use these machines to make really, really cool stuff. And I think that's exactly what's going to happen in this movement, is we have a few companies that will own the machines, meaning the large language model that knows how to do what our brain does. But then the winners among you right now in this audience, and hopefully my company as well, will be about taking that and turning it into something that's truly solving world problems in a very, very significant way. So I advise you all to be looking at that, thinking from that perspective. How can we use this amazing new technological capability to create value? And there is room for all of us to create value out of that, not just the big players. That's my belief.
So I really haven't told a story publicly before, but a bit about my own journey. So in the 1990s, when we first started BEA, 1995, my mission in life was actually focused on one single thing, which is, I don't get scared, I just met Alexei, to kill IBM, okay? Because the world was only all running on the mainframe. All the jobs that goes into this computer has to be run in a data center. Most of the computer back then were water cooled, were liquid cooled, right? So I don't know, we're back to liquid cooled a little bit on the GPUs. But nevertheless, the whole large computer is like a car, is, and they're very big. And all the jobs are batch. So that means that's the reason why sometimes you still see banking transactions that it'll clear the next day because they're waiting for that job to go in. So my mission was to get rid of that. I want to go to real-time computing. So then I had an opportunity of lifetime, which is in 1999, a rumor is spreading that in what we call Y2K, year 2000, December 31st, 2000, the mainframe will stop because those were 8-bit computers, okay? And then so I ran the largest marketing campaign to spread the word that said it will die, okay? So then everyone, just as a backup, starting to rewrite the application and move to distributedly, obviously mostly on me. So I benefited the most in that exercise, and they never looked back. And then obviously it got just transformed into the cloud, and that's where we are to this day. So some of those, I think, important moments are very, very important to building a company. And I think things that as students in a great institution like this, we learn to go build those for that reason. It's not just one thing. It's not only we have superior technology, but being able to be innovative in the ways that we go to market, package our technology, find adoption, right? And getting people interested in what we do is super crucial. Now, with that in mind, we're right at that time that we would love to open this up for some questions in the audience and have a much more livelier dialogue starting from this moment on. So you can ask any questions. I'm reserved for you. I don't have much answer for you, but he does. Okay, so yeah. Do we have a mic in the room? I think there's a question
Hi, thank you for the talk. So you mentioned kind of...
Do you mind saying your name? And
Oh, sure. My name's Chris Pico. I'm actually a Stanford grad who lives in Berkeley. Sorry about that. But I'm building this kind of literature-based AI thing. I'm all excited about this. But I also studied political science. I worked in government as well. You talked about getting rid of the form. I can feel it. There's a lot of anxiety about AI basically making millions of jobs obsolete, and it's just seeming to get faster. Like those forms, there's people who have the job to process the forms, and whatever. I mean, they're unleashing the technology. It's strange that these institutions rely on these forms. The jobs are built on that. Our government doesn't seem to have a big planning structure to rework the economy. I don't know. Just what are your perspectives on the possible disruption of this technology in the labor market?
Again, I'm a big believer in learning from the past as much as we can. And the Industrial Revolution, when it came, the same exact thing happened back then. There was riots in the streets, people walking in the street and saying, oh, the machines are going to make the shirt faster than we can, but we make the shirt better. Let us keep making shirts. Oh, the machines are going to build a skyscraper in a fraction of the time that we build a skyscraper because we now have cranes that can move things way quicker than we can. Can anybody in this room say that was not good for us as a civilization? The fact that the Industrial Revolution allows us to expand at a level that has never happened before in our history. We became, sorry for using this term, superhumans because of these machines. We were able to build buildings and bridges and things that we could never even think of before. So that's how I look at this, what's happening right now. Yes, there will be some interim job reallocation because of this. But history has shown us that as we get more efficient and productive of doing things, we are, most of us, most humans, we are agile enough to adapt, to start using them to our advantage. So here is one of the best examples of AI doing that to us, to all of us right now. First show of hand, how many of you in the last month used Google Maps or Waze? Okay, 100% of the room raised their hand. Google Maps, under the hood, is using some of the most complex AI you could think of in terms of how it does the mapping, the prediction, the traffic, etc., the satellite imagery, stitching them together. An amazing amount of AI is going in the background. We are all using AI. Your mom is using AI, your sister is using AI, your daughters are using AI. We are using it already. Before Google Maps, very few of us were good navigators that know how to read a map and get from point A to point B. Right? Very few of us, and we would have fights in our cars with our girlfriend, boyfriend, or many of you might not have experienced that, but we all had that. Or ask somebody in the street, and they would lie to you about when to take right or when to take left. It was horrible. It was horrible. It was really a bad time. And now, thanks to Google Maps, we are all expert navigators. The average human became an expert navigator, became a superhuman when it comes to doing that. Stability, AI, and stable diffusion with generative. Any of us now can be an amazing artist because of this technology. And that's exactly the power that excites me about what's happening right now. That we will become a lot more productive. We will be able to do things that we could not have done in the past. And that will be for the betterment of human civilization. Now, will everybody have jobs in this new world? That's a big question that I don't know the answer to. I don't know if Alfred wants to comment on that.
Well, I'm going to argue that they will. I remember, I think this is the most vivid, I think example that I saw was all the way into the 2000s. If you will have traveled to Tokyo, they will still have people that are clipping the tickets in the subway, right? Which I couldn't understand it because I was already selling the most advanced platform for the Nippon Telephone, for the Japan Rail to build application. I was thinking, that doesn't make any sense. But government generally is the last, basically, to adopt mostly because it's the consensus organization for human innovation. So I think any time that we have such dramatic technological platform shift, it's great because it forces the government's hand to move it, click it to the next level. Then I think for the people that will be slightly behind in the adoption, at that point in time, they will have to adopt. You know, my mother is 92 years old. She is so proficient on this iPad, and everything she does, it's just truly is amazing. But she was I would say definitely a lagger in adoption, but she caught on completely because it's needed, because then you have consensus organizations that are pushing it to happen. So my guess is, I don't think this is something that we have to be overly worried about. I think the things that I worry about a little bit more has more to do with ethics, governance, regulations, because like all technology, we are now basically is ripping it wide open. Everything is a goal, and likely people will cheat. And we have the same worry that's when like the calculator was first invented. I said, oh my God, all the students not going to know math anymore. They're all just going to cheat. But that didn't quite happen. So now we're going to have to follow up with proper governance. I mean, without a doubt, GPT-3 and GPT-4 are extraordinary, dangerous technology in the hands of children, for example, what they will be able to do, what they'll be able to learn out of it. And it can do deep fakes to a point where we can't tell is fake or is real. So those things, without a doubt, is good.
Fake right now, Alfred, or this the real Alfred?
I hope it's real. Okay, so, but I think those is going to need governance and regulations to be able to provide the proper guideline. This we may see one of the earliest of governance body to step into a technological implementation than anything that we will likely see, which makes sense, right? As technology becomes so reliant in our daily life, we need more governance. Yeah. Questions?
So let's take a question from the front here.
Yep.
And then we'll go back to the back.
Yeah.
Hello, I'm Praveena Dhanalakota. For the last decades, I've been in the conversation space, and I built the first chatbots for Wells Fargo. And now I'm a founder of Mimeo, where we are building the world's first personality engine, where you could create your digital twin with your own digital data. I think there is a synergy with the Vectara there. So my question I always wondered during all the experience is about responsible AI. I wanted to ask you a question about, do you have a related experience and lessons that you have learned that you're applying in Vectara about responsible technology innovation?
I mean, Vectara is still a small company right now. We're 20 people. So we have one goal and one goal only, is to create a product that sells over and over in a good way right now. Any other problem is secondary. But that doesn't mean that we're not responsible in terms of what we do. Now, one of the key areas that we are double-clicking on in terms of responsibility is a very common problem that many of you might have heard of, which is the hallucination issue. And that, by the way, that's the technical term that we described it with, which is large language models sometimes, actually many times, they just lie. They literally just lie, like humans lie as well. So it will make up stuff that is not real, but it would say it in such a very convincing way that you would think it's real, and you would think it's right. And that's why it's dangerous with children. Like children might go ask a question, why is the sky blue? And if the large language model doesn't know, it will make up an answer that sounds real, and the child will think that's the answer, and go ahead with that. So one of the key issues that actually we're very focused on at Vectara is exactly that. How do we analyze the facts under question, both in terms of the input to the large language model, but also the output, to make sure it's not making up shit, to say it bluntly. So that's how we're trying to be responsible right now. That's the only responsible dimension we're focused on, but there's many other dimensions of responsibility. For example, some of these models, they can have political biases, where the model could be more liberal in nature, which is, if you're liberal, that's great, but if you're not, then that would not be a fun experience, to be talking with a model that is trying to advocate ideologies that you don't really believe in. And hence, we need to be able to adapt for that as well. So there's so many areas of responsibility that we need to be very cautious about. Yeah.
Thank you very much.
Yeah, I think for the past decade, I've been very focused on investing in the big data and wall-in machine learning, classic decision-based machine learning. In those cases, you don't run into these cases because we don't have NLP, we're not trying to make stuff up, right? So obviously now, because we're obligated to return an answer, so automatically in the vector, you will be heading towards stuff that will be way out there that we're not even sure, and the probability goes down dramatically. So that's a major issue, which is why I'm excited about is having 95 or 99% of the actual large language model is running on the Wallen data itself that we can filter and we understand, we can check, we can regulate that we know has high level of accuracy, and only use the last mile for basically the compilation of the answer itself. I think that would likely be the case. Let's say if you're going to re-implement a new system at Wells Fargo, I would hope that they would do that, right? So they will use customer data, actual trading data, not just make stuff out and say, I think the world is collapsing today, and start spilling rumors everywhere, right? So we have humans spreading rumors, it's about enough, right? Like last week. We don't need any more of that. So I think this is one area that's going to be extremely crucial. So I would imagine as we progress along, banks, telcos, pharmaceuticals, healthcare starting to develop applications running these kind of platforms, they will have much higher reliance on absolute data than they'd be using on outside data. Yeah.
Yes. And validating the accuracy is so important. If we want to move from search engine, answer engine to action engine, which means kill the form, you cannot be inaccurate. I cannot say, oh, I want to drop from this class, and then it goes and drops you from all classes. Or I want to move money from this account, and it just moves all of your money to a friend's account. Like, we have to be very, very accurate before we can reach that step. And that's one of the key problems we're all working on.
Yeah.
Hi, Dragan Petrovic, alumnus, did my graduate work across the street as well. My question was related to the same thread of semantics and uncertainty. And so how close are we, and what would it take to deal with those issues, to be able to either provide a certainty level when it gives a response, this is how sure or unsure I am about the response, as well as providing a reference for this is why I think such and such, and here's where you can investigate more, because I cannot be certain. Given the way the model is structured currently, stringing words together, is there an understanding of where the information really can be verified or can be followed up on, and how likely it is that it's true? Yeah,
excellent question. Excellent question. That's actually one of the core things we actually do at Vectara. So at Vectara, we follow a combined approach that I invite you to go read more about if you search on YouTube or anywhere else. It's called the Retrieval Augmented Generation. That's the name of the approach. So retrieval is about finding the underlying facts that's backing up and relevant to the question or the statement that the prompt is exploring. And then you only take that content, and that's what you pass into the large language model, and ask it to now, using that content, to summarize a cohesive answer that responds to that question. The answer comes out, the answer has in it the references. So it says the first sentence came from this result, the second sentence came, so you can go back and trace back the lineage. But still, every now and then, the large language model might add a sentence from its own mind. And that's where we're having some work to do right now, is to look at these additional sentences, which sometimes, by the way, are correct, and see if we can validate the level of confidence that we have in them. And so that's an active area of research. That has not been done right now. That's something that we're all working on very fast to try and solve. But at least what we do have right now is we do give you the references back. And in fact, Bing Chat, if you were to use Bing Chat right now, which is powered by GPT-4, you will see it does that. Like Bing Chat, when it gives you the response, it will, for every sentence, there will be a footnote that shows where this conclusion came from. So that is now adding more confidence to us that we can trust this. I equate this exactly to what happens to us humans. If I'm a reporter working for the New York Times or the Wall Street Journal, when I finish writing up generating my article, it doesn't just get published. It goes to an editor, it goes to a fact-checking team, they check it out, make sure the facts in there are correct before it goes out. And that's kind of what we need to happen also for these algorithms. Make sense?
Well, the answer is lineage is extremely critical. Yes. And when you're building inferences, if you don't know where it comes from, it's extremely dangerous. With that, I think, thank you very much for this sessions. It's a great chat. So, yeah. So, well, one more question, I think. One more question.
Sorry. No, I misunderstood you.
One more question and then break.
Okay, one more question, break. Okay, all right. One last question, please.
Thank you for answering these interesting questions and interesting discussion. I'm Julia. I'm a Berkeley Haas MBA candidate, and I'm also a co-founder of an AI-based startup. And we were selected to Berkeley Launch Accelerator. We are currently there. And my question is, what kind of metrics you recommend to track for AI-based startups, if you have any specific metrics? And what are peculiarities of AI-based startup valuation also? Again, if there is any peculiarity.
So I can talk about metrics and then let you talk about valuations. So metrics depend on what you're doing, but the ultimate metric of any product in general is adoption, right? And in the first stage of your startup, that is the number one thing you should be worried about. Like, am I finding the proper product market fit, where there is a developer or a user or a customer that is using me in the way where they want to come back and use me again and again and again? And that's the key metric that you should be focused on. Now, how you measure that metric depends on your product. So I cannot give you an answer how specifically you're going to measure that, but that's the number one metric, bar none, in your early stages. Later on, of course, as you have proved traction and repeatable tractability, meaning it's the same product now being adopted in the same way by many customers, then that's when ARR, which is the average recurring revenue metric, starts kicking in. But before that, the thing that will make you or break you is the adoption metric.
Well, this is $1 million question. So I can attest to only one thing. There's nothing in the world harder than Gen AI or AI in general, actually. So data, big data, and almost you can actually put the pound sign in front of it. Data, big data, machine learning tooling, Gen AI are all the hardest thing on the market, because people see the potential what the world's going to happen. And I would say, despite I think we're having almost a winter in terms of funding for tech companies, late stage company are seeing big valuation drop over the last year. In early stage, deals are extremely hard. So if you're doing AI, it's enabling businesses. Life just cannot be possibly better. As our team is doing nothing but looking at different AI companies. We have to do account how many we looked at this week. It's an extremely exciting time, because it's not only because individually technology was doing a specific thing that intrigues us. There's no doubt that we have that. It's almost like a fad. But we can see the potential how things will work so differently in the future, what we'll be enabled by. For example, a really good one would be the future of consulting an internal medicine doctor will likely be done by AI and not human, right? And the chances of that AI technology will be better than a doctor is extremely high, right? Because it has data. It has absolute data to know, with these conditions, with these symptoms, if I can diagnose them correctly, these were the cure that worked, right? You're not guessing by remembering what you learn along the way and experience in a medical school. So nothing can compare to that. So it's coming. So the world is excited about it. But I will go back to the point. How we will select the company is to look at what business can you build out of it. Excitement alone is not going to be sustainable. It has to be a way that you can actually apply in business. It helped the world get better, and grow and generate revenue. So that's very key. So think of that quickly as you're building these technologies.